Viewers, I'm here to present the 14th video lecture of pavement construction. Under this video lecture, the topic batching of hot mix asphalt is included. Let us proceed to the batching of hot mix asphalt. The plant production of hot asphalt consists of hot mixing aggregates with bitumen in a special plant in order for the in order for the for producing asphalt to be homogeneous and in accordance with the target mix composition. Before adding the bitumen, the aggregates are blended at a predetermined portion so that the required or target grade is achieved. Before or after blending, the aggregates they are heated to dry and to rise them to a temperature suitable for bitumen coating. Hot mix asphalt plants are installed close to the aggregate production source or quarry in suitable rural location near the expected project or at the project site. The mixing plant can be stationary or mobile. The mobile plants provide flexibility and are less costly, but daily production output as high as those of stationary plant cannot be achieved. Now let's proceed to the types of asphalt production plants. All types of asphalt production plant consist of five distinct parts, which are the cold aggregate feeder system, the dry or heater, the dust collection system, the mixing system, and the storage bin. The mixing system is basically the factor that determines their categorization. There are two basic categories of hot mix asphalt plants. One, batching plant, and two, drum mix plant. In batching plant, the hot aggregates are stored in hot bins before mixing with bitumen in discrete batch in a pug mill mixer and then loaded onto truck or transferred to a silo for temporary storage. In drum mix plant, the mixing of aggregate and the bitumen takes place in the dryer or heater drum, after which the asphalt is stored in silo before using loaded onto delivery trucks. Into the above two categories split into two subcategories. The first category split into conventional batch plant and batch heater plant. The second category split into parallel flow drum mix plant and counter flow drum mix plant. Now let us proceed to batching plant, which is conventional batching plant. In this type of mix plant, the asphalt is produced in batches of predetermined weight and the heating of the aggregate proceed both the determination of the batch weight and the asphalt mixing. The batch weight may vary from 1,000 to 5,000 kg depending on the plant model. Cold and damp aggregates outflow from feed bins and a conveyor belt are fed into the rotating heater drum, where they dry and obtain the desired temperature. Feeder units are located under each bin to control the flow of aggregate onto the conveyor belt. To eliminate dust from the dried exhaust, dust collectors are fitted. The hot aggregates are transported by a bucket elevator into the screening or separation unit, where they are stored temporarily in hot bin. Separation is carried out by specified series of sieves. For each hot bin, the aggregate is charged into the weigh hopper that is weighted at a predetermined amount and then discharged into the mixer. Fines or filler together with hot bitumen are also added to the mixer at a predetermined amount. If reclaimed asphalt is used, it is added either directly to the mixer to the superheated aggregate before screening or in the heater drum. Hot aggregate reclaimed asphalt, if used, filler and hot bitumen are mixed for a certain period and the produced asphalt is directly unloaded onto the pending truck or transported by skip to a temporary storage silo. A schematic representation of batch plant is given in the figure below. This is a typical layout of batch plant for hot mix asphalt. Now let's see the required mixing time is affected by the type of asphalt produced as well as the batching quantity. As a consequence, the mixing time and the batch quantity determine the hourly production output. The basic advantage of a conventional batch plant, which is usually stationary, are the following. They are flexible to produce all types of asphalt. Small tonnages are possible to produce. High percentage of reclaimed asphalt can be added. Storage of mixed asphalt is not essential and emissions are within acceptable limits. The basic disadvantage of conventional batch plants are as follows. High capital costs, relatively high maintenance costs. Overall, higher production costs over drum mix plants. Heat and aggregate materials wasted on overflow material. Capacity being restricted to mix cycle and mixer size. Now let us proceed to the storage feeder of aggregate and reclaimed asphalt. Aggregate and reclaimed asphalt, if used stocked in piles, are placed in cold feeder holding bins using a loader or truck. The number of cold feed bins is usually from 3 to 9, depending on the number of different size aggregate used and hourly production output. The dryer or heater drum. The role of the dryer and heater system is significantly important, given that the amount of water or moisture usually contained in the cold aggregate should be removed within a short period and the aggregate should reach the appropriate temperature to be coated with bitumen. Separation of hot aggregate units. The separation or screening unit includes a series of sieves that separates hot aggregates into fraction of specified size and reject the oversized aggregates. The fraction of aggregate are stored temporarily in hot bin. Each bin is equipped with an overflow tube of appropriate diameter to prevent the material from overflowing into another bin. Weighing system of aggregate materials. The weighing cooper is positioned exactly under the hot bin. Each aggregate fraction is individually weighted in a specified portion with the with the added filler to obtain the target gradation. Weighing usually began from coarse to finer aggregates. The weighing system should periodically be calibrated to attain gradation within the specified variation limit. Now let's see the supply of bitumen binder. Supply of bitumen binder. The bitumen binder is supplied to the mixer by an appropriate pump. The amount of binder needed per batch is measured volumetrically by a flow meter or by a weigh bucket. If bitumen binders quantity is measured volumetrically, the change of the specific gravity of the binder with respect to operating temperature should be taken into account. Mixing. Mixing of the preheated, pre-weighted aggregates, filler, and bitumen is carried out in a pug mill mixer. This is a large semicircular bowl with two shafts with mixing blades carrying adjustable hardened steel tip. At the beginning and for a short period, aggregates, filler, and additives, if used, are mixed alone in a dry condition. Parallel flow drum mixer. As you have said, this is the second type of mixing plant. The parallel flow drum mixer plant use drum mixer in which the burner discharges superheated air parallel to the direction of aggregate flow. The wet ambient condition is fed to the rotating drum where it is mixed with the bitumen and the asphalt is conveyed to the thermal insulated storage bin before being loaded to the truck. The reclaimed asphalt, if used, is added to the drum mixer after the first half of its length. Let's see the advantage of the parallel flow drum mix plants are as follows. Lower capital costs in comparison to batch plants, lower space requirements, higher output can be achieved adaptably to mobile units. Relative lower maintenance cost and economical for long production runs. The disadvantage of the parallel flow drum mix plant are as follows. Fume emission increase if high mixing temperatures are used. Low percentage of reclaimed asphalt used, which is from 10 to 50%. Uneconomical to produce small batches. Difficulty to produce all types of asphalt. Single-sized aggregate feed and wastage of materials at the beginning and ending of production. Let's see transportation. The transportation and delivery of the hot mix asphalt from the plant to the paver are carried out with haul truck, which should be insulated and sheeted to prevent heat loss and to protect the hot asphalt from bad weathering conditions, especially rain, winds, and low air temperature. Additionally, the floor and the wall of the haul truck must always be clean and free of foreign materials to avoid intermingling and contamination, and flat and free of dimples. Laying off, laying down operation of hot mix asphalt. Laying off the hot asphalt is carried out with special motorized units called pavers. Pavers are available in a wide variety of sizes capable of laying mats from as narrow as 1 meter to up to 16-meter wide. The minimum and the maximum range of paving widths vary from one manufacturer to another. The pavers are distinguished from the type of their traction, and there are two types: the wheeled paver and the tracked paver. In the first, the traction is provide via driving pneumatic wheel, and in the second, the traction is provided via driving crawler track. These two different types of pavers are shown below. This is tracked spray paver, and the wheel paver provide excellent maneuverability, have the advantage of being driven easily for short distance and require less purchase and operation costs. They can pave mats normally up to 9 meter wide. Wheel paver dominates the market in the most countries. The track paver, owing to long and stable track, assure very good grip, stability, and maximum traction even under difficult conditions and exert less pressure on the underlying layers. They can pave wider mats compared to wheel pavers, which can be as wide as 14 or even 16 meter. Both asphalt paver consist of two basic parts, the tractor unit and the screed. Some manufacturers offer pavers that are also equipped with spray in front of the screed for spraying the tar coat. These pavers spray tar coat and apply the hot mix asphalt second later. They also known as spray paver or integral parts. Finally, pavers that can simultaneously lay two asphalt layers in a single pass have been developed. This results in better interlocking of the cores, eliminating of tack coating and the reduction of the paver time. The method is known as compact asphalt laying method. Let's see track units. Tractor units. The tractor units, as mentioned, move on pneumatic wheel or crawler track, and its aim is to pull the screed, receive mixture from the track and transfer it to the paver, and provide mechanical, electronic, and hydraulic energy for the function of all system of the device. The basic components of a tractor units are the following: hooper, push roller, conveyor, flow control gates, side arm, auger, and automatic automation and control panel. Let's see the first one, which is hooper. The hooper is the area where the hot asphalt is discharged from the truck or lorries. The side of the hooper or wings can fold hydraulically towards the center to ensure that all the materials are pushed onto the conveyor. The capacity of the hooper depends on the mold of the paver, and in most models, its capacity varies from 5.5 to 6.5 meter cube, which in terms of mass is approximately 10 to 13 tons. The width of hopper is normally a bit wider than the width of the delivery track. This is approximately 2.5 meter, but in some models it can be up to 3.5 meter. Push roller. The rotating roller are mounted at the front of the paver, and they are in contact with the tires of the delivery trucks and used to push the delivery truck. Conveyor. The conveyor is the mechanism that moves the hot asphalt from the hooper through the paver to the auger in front of the street. Flow control gate. The flow control gates are adjustable metal plates that control the amount of material flowing out of the hooper by changing the height of the operating at the hooper. Side arms. The side arms connect the screed to the tractor at the toe point and tow the screed. The tow points are height adjustable and dictate the thickness of the mats. Luggage. The auger receives the material from the conveyor and distributes it transversely and uniformly to the to the full width of the screed. The auger's speed and height can be adjusted. Changing the height of the auger is required when the layer thickness of or the mix coarseness is changed. Thus, the performance of the device is maximized. The start and stop of auger's operation as well as the rotating velocity are determined by the operator. Automated or automation and automatic level and slope control. The tractor unit also carries also the automatic automation for materials handling and the automatic level or grade and slope control device. The automatic level control device cater to the layer's thickness and its evenness. Today, there are various types of sophisticated automatic control level system, but all of them work on the same principle to maintain tau points at a constant height from a reference datum. Street. The street is perhaps the most important part of the asphalt paver. It is essentially a wide flat piece of heated steel that level and pre-compacts the asphalt placed in front of it by the auger to a specific width, grade and cross slope or crown profile. All asphalt streets are of the self-leveling floating type. In other words, the street floats on the asphalt seeking the level where the path of its flat street plate is parallel to the direction of pull. A floating type street is shown below. This is a floating street detail of an asphalt paver. Compaction. The compaction of asphalt layer is possibly the most critical stage of asphalt work. It is needed to achieve proper and uniform compaction, which in turn ensure a better long-lasting performance. During compaction, the coated aggregates are compressed, are reoriented, and take such positions that the distance between them becomes smallest possible. As a consequence, the air void decreases and the mixture density increases. Let's see the different types of compaction equipment. The first one is static steel wheel roller. Static steel wheel rollers are developed first and are used in all rolling or compaction phases. Static steel wheel rollers are available in two basic types: the tandem steel wheel roller and the three steel wheel roller. The tandem steel wheel roller bears a steel drum at the front and a steel drum at the back, while the three steel wheeled roller shown in figure below bears two steel wheel at the front and a steel drum at the back. Let's see this triple wheel steel static roller. The next one is vibrating roller. Vibrating rollers are widely used in all asphalt compaction work because they are very versatile and effective, especially when thick mats are to be compacted. This consists of two smooth surface steel drum equipped with a vibratory system. The compaction through the combination of static and dynamic loading. Modern vibrating rollers are capable of varying both frequency, and amplitude. Figure below shows the drum, double drum vibrating roller. This is double drum vibrating roller. The next one is pneumatic tire roller. Pneumatic tire roller consists of a number of tires, usually 7 or 9 in total, and the number between the front and the back tires always differ by one tire. An example of pneumatic tire roller with 4 tires at the front and 3 tires at the back is shown in the figure below. This is pneumatic tire roller with 4 front and 3 back tires. Pneumatic tire rollers differ from the steel roller in respect to the way they compact. Compaction with pneumatic tire roller takes place under a needling action. The advantage of pneumatic tire roller is that the contact pressure can easily changed by changing the tire pressure. Modern pneumatic tire rollers have the ability to change the tire pressure during operation. This is all about today. Thank you for your attention.